In this video, I will talk about inverse sine functions and we will discuss some examples on that. Inverse sine functions are very important in engineering and sciences. Suppose we have a function y is equal to sine of x. Rather than looking at the range of the function, we are interested in the domain, which is the angle. For example, if we want to see, for example, y is equal to sine inverse pi by 4 or something. So what we do, or maybe we are interested in sine of theta where we have 1 by 2. So in this case, we need to find the angle. We are not interested in what is going on when we have sine 45. So this is the motivation of studying inverse sine function. Inverse sine function seems to be a very straightforward function, but it is not a straightforward function in terms of inverse sine function. You will see the reason now. First of all, when I sketch y is equal to sine of x, when I plot that function from 0 to 2 pi, so 0, pi by 2, pi, 3 pi by 2, 2 pi. So we can see that when we plot that, sine 0 is 0, sine pi by 2 is 1, sine pi is 0, and then we have sine 3 pi by 2 is minus 1, and then we have sine 2 pi, which is 0. We know that in order to find a inverse function, we should check that either that function is 1 to 1 or not. So for 1 to 1, we have a horizontal line test. Horizontal line test says that when you draw a line on a function, if it passes through only one point, then that function is 1 to 1. But here you can see that there are two points where the horizontal line passes through. So it is not 1 to 1 function. It is not 1 to 1 function. Now what we do? The problem is we have to find the inverse function anyway. So what we do, we try to restrict the domain. I restrict the domain, and for example, I want to make this function 1 to 1. If I just remove some part of the domain and consider only this, then still it is not 1 to 1. So I start removing the domain until I get 1 to 1 function. For example, if I just remove that part as well, and now I see that this is 1 to 1 since it is just passes through only one point. But one thing I observe over here as well, and for that I need some space. Sorry. Suppose that rather than extending the domain from 0 to pi by 2, I just want to see 0 to minus pi by 2 or minus 2 pi as well. So when this function continue its journey like this until minus pi by 2, we can also see over here that the function is still one to one, since horizontal line passes through it and the horizontal line passes through it at only one point. So this is one to one function. So smartly, what we can do, we can have minus pi by 2. We want to include minus pi by 2 in the domain as well, and we also extend the function from minus pi by 2 as well. We extend that to the minus pi by 2 as well. So this function is one to one. You can draw any horizontal line and it still passes through one point. So it means that in order to find a inverse function, we must have a domain minus pi by 2 to pi by 2, and the range is, for example, this is 1 and this is minus 1 over here, not over here, maybe over here, something like that. So that's how we restricted the domain. We first able to get one-to-one function. Okay, so we write y is equal to sine of x, and the domain is minus pi by 2 to pi by 2. That's how the things are done for inverse function. And the range, this is domain and the range is minus 1 to 1. The range remains the same. The maximum function can go upward is 1 and the downward it is minus 1. So what we do, we replace x with y and y with x. That's how we can find the inverse function. So replace x with y, x by y, and y by x. So y becomes x and x becomes y. Now we know that the domain becomes range and range becomes domain. In that case, y will be minus pi by 2 to pi by 2. That is the domain for the inverse function. The explicit form of this function will be y is equal to sine inverse x. So that's how we define the inverse function. Okay, let me just draw it for you so that you can better understand the function itself and the inverse function. So this is y is equal to sine x. Let me just draw the y is equal to sine inverse x. When I draw sine inverse x, we know that we interchange the values of x and y, but at the end we put the values minus 1 and 1. So this is the domain for sine inverse x. So when we have, this is pi by 2, this is the range for sine inverse x, and this is the range for sine inverse x as well. You can see that these two values -1 to 1 are -1 to 1 are the domain are the range for y is equal to sine x, and minus pi by 2 to pi by 2 is the domain for sine inverse x, and -1 to 1 is the domain for, we actually changes, as we know that we have to change the values for x and y, so on. So we plot the domain and range on the x-axis. Okay, so when we have -1, the answer is minus minus pi by 2. The answer is minus pi by 2 over here. When we have x is equal to 1, then we have the answer is pi by 2. Okay, we are plotting the inverse function now. So as we continue with this, you will see that this is the inverse function. Y is equal to sine inverse x. This is y is equal to sine inverse x. You notice that on the y-axis we have pi by 2 and minus pi by 2, and on the x-axis we have -1 and 1. So roughly this is the reflection against y is equal to x. So y is equal to sine inverse x is x is -1 to 1, and y is minus pi by 2 to pi by 2. So this was the sine inverse function. Let me just quickly solve one example for you. Example: we need to find the value of y is equal to sine inverse under root 3 by 2. We know that under root 3 by 2 is -1 to 1. So it is -1 to 1. So it satisfies this domain condition. It should be between this range for this domain. And also what we do, we see that sine of y will be equal to under root 3 by 2. Just taking sine, applying sine on both sides, we get under root 3 by 2. And we also note that the range is y is minus pi by 2 to pi by 2. Y should be minus pi by 2 to pi by 2. So y will be equal to pi by 3, and pi by 3, as you know that this falls in this interval, it belongs to minus pi by 2 to pi by 2. It should belong to this this range. Okay, so that's how we define a sine inverse function, and that's how we find the value of sine inverse function. Thank you for watching.